topic is hey?
Percona monitoring and
Oh yeah,
management.
for monitoring and management. One more second.
If I stand, is it still visible?
Yeah, so your view is from that corner
Okay.
until here.
Okay, cool.
If you move around in this area,
Yeah, probably I will sit for a while when I demo, but otherwise I will
makes sense.
stand and deliver. Can we start?
All right, welcome back everyone after lunch. I hope everybody had a good lunch. So now we have Puneet from Perkuna. He's come all the way from Indore, from the city of, I would say, Nawabs and poetries.
Probably food.
Food,
Also.
yeah. So take it away, Puneet. All yours.
Cool, thank you. Hi everyone. Thanks a lot for coming to the session. So I am based out of India, and I have been associated with Percona for about 5 years now. I work with the PMM team, and today we are going to look at how you can use Percona monitoring and management to monitor the databases that you are running. And we're also going to look into some of the features that it offers out of the box. Um, so I'll just go over what PMM is and then take a quick review on the architecture of PMM, jump into the monitoring side, and then we'll look at the query analytics feature in PMM, talk about advisors, what are advisors in PMM, and then we'll have some demo on backup and restore in PMM. And finally, if time permits, we are going to look at how you can manage and how you can use database as a service in PMM. So let me start. So basically, what is PMM? It's an open source database tool that primarily focuses on allowing you to monitor your databases. It gives you an ability to analyze the kind of workload that you are running on PMM, on your database, sorry. You get the capability to troubleshoot any performance issues. And on the top of that, we also provide you features on managing your database. Currently, we have support for backup and restore on MySQL and MongoDB. And we are also planning to GA very soon our database as a service feature. That's going to allow you to run Percona operators and deploy DB clusters on your Kubernetes infrastructure. So before going into the monitoring demo, I just wanted to quickly cover an architectural overview of what PMM is, or how basically PMM architecture looks like. It's not an in-depth analysis, but probably I have referred the documentation where you can go in and check more details around how PMM actually works. So we've got a PMM server and a client, where PMM server consists of some of the components that Percona built. For example, PMM ManageD, that's basically the brain behind PMM. We use Victoria metrics as our time series storage database. Basically, all the metrics that we collect from the clients are stored in Victoria metrics. It's completely compatible with Prometheus. So that's what we use as a time series database. We have query analytics that under the hood uses ClickHouse to store query metrics. And then we have Grafana, which is basically the UI layer in PMM that lets you look at the metrics and all the dashboards that we ship with PMM. On the client, we have PMM agent. That's the component that is built by Percona, and it communicates with PMM ManageD. So if you have multiple databases, you install PMM client on each database host, and it would set up different exporters that we've shipped with PMM client. And then there is VM agent, which is basically a component responsible for pushing metrics from the client node to the PMM server instance. So PMM basically supports two mode in which you can gather metrics from the client instances. One is a push mode and the other is a pull mode. The difference is in pull mode, the server is actually reaching out and trying to gather metrics from the client instances, while as in push mode, you have clients pushing the metrics to PMM server. Let's talk about what kind of monitoring options we have in PMM and what all databases do we cover when it comes to monitoring in PMM. So as you can see, PMM basically supports most of the majorly used databases. We have support for MySQL, PostgreSQL, MongoDB, and basically I would say monitoring is a bread and butter for PMM because we ship PMM with a lot of custom dashboards that primarily are built by our database experts. So these dashboards, they come from internal experience dealing with customer issues and trying to capture how you can troubleshoot a customer performance issue. So I will quickly show you people on a live instance of PMM that I have, where you can actually look at the number of dashboards that we ship for different databases. We also have support for monitoring cloud database. So if you are using Amazon RDS or Amazon Aurora instances, if you have GCP, MySQL and Postgres instance, or if you have a Microsoft Azure MySQL and Postgres instance, you can monitor that using PMM. I would say one of the most important and a great feature in PMM is the external exporters. Basically, external exporter is if you have a service that PMM doesn't support by default, but if you have an exporter available in the community, you can start monitoring that service using the external exporter feature in PMM. So let's quickly look at how the monitoring looks like. So this is the home dashboard of PMM. I should have changed the theme to white, but yeah. What you're looking at is basically it's showing you how many databases it is monitoring at the moment. I just set up this instance for test and demo purpose, probably a few hours ago. What you see here is there are 2 MySQL databases, 4 MongoDB and 2 PostgreSQL databases that PMM is monitoring. You get an overview of all the nodes and the health, CPU usage, memory usage on the home dashboard. And when you add an instance in PMM, you basically get to see the instance detail. For example, let me quickly show up MySQL instance summary. So I added a MySQL instance for monitoring in PMM, and as you can see, it is shipped with all the dashboards that we build internally and ship with PMM, and these are all custom dashboards. And you can see here, you can filter by service that you want to basically monitor. So there are 2 databases that we are monitoring, and you can see that the metrics are hitting PMM server. I'll quickly jump onto the setup part and try to talk about it. So how do you set up monitoring in PMM? It's pretty straightforward. You need to have PMM server running, and you can install PMM client on the database host. Once you have PMM client installed on the database host, you can config the PMM admin command to connect the client and server. Once the connection has been set up, all you have to do is create a monitoring user according to the docs that we have. And once you have set up your monitoring user, you can use PMM admin add commands to add specific databases for monitoring. There is a lot of help instructions available. So if you run PMM admin add help commands, you will basically see an entire list of supported command line options and all the list of databases that we support in PMM. Let's talk about query analytics. So query analytics is, I would say, one of the most important feature in PMM, which basically allows you to monitor the kind of workload that you are running on your database. What kind of queries are being executed, and what's the query that basically needs some have some performance issues. We support query analytics for all the 3 databases, as you can see, and there are different query sources that you can use to monitor your query performance. If you want to use Slowlog, you can use Slowlog or performance schema in MySQL. In PostgreSQL, we have pgstat statements and pgstat monitor. pgstat monitor is an extension that Percona has built. It's a custom extension that you have to install on your Postgres database. It basically seamlessly integrates with PMM. So it's an in-house tool. It's an open source tool, and it gives you far more better insights as compared to pgstat statements. Let's quickly look at query analytics as well. So on my test instance that you're seeing right now, I added 2 MySQL instances, and one of them was basically added using Slowlog. How do I get to know what kind of instances I've added? You can actually see it either on their individual dashboards, or you can even go to the PMM inventory and you can try to look at the services that you have added. And here you can clearly see that I have got two MySQL services running. One is MySQL check service and the other is MySQL client flow log. If I want to see what is the query analytics on a specific service, I can go to query analytics using the menu in PMM. I'm just going to filter by time range because I ran a specific sysbench workload a few hours ago. Here, what you're seeing is all the queries across all the databases and all the data coming from them. What I wanted to show is the MySQL service that I added with flow log. So I can do that in multiple ways. I can either use the service name filter if I already know the service, or I can use even the technology if I want to filter by MySQL databases only. So as you can see, there is an SB test queries that are being executed, and all of these queries are the load that I ran on my database. When I click on a query, I can clearly see that there are metrics related to the query execution time, how many times the query was executed. You get to see examples and explain of a query, and you can actually gather a lot of metrics similarly for PG database as well as MongoDB. So this is how query analytics looks like in PMM. There is also an option for you to add a different metric. So for example, right now what you're seeing is PMM query analytics is showing you metrics for load, query count and query time. But if I want to use a different metric, I can use that using the add column feature. And there you get a bunch of metrics that you can basically use in query analytics. For example, let's say I want to look at the byte sent data, and I can see that byte sent information is available on the query analytics. I can make it my main metric, and it will basically sort all the queries based on the byte sent that I have for in QN. Okay. So we have looked at the monitoring part where basically we have dashboards showing you metrics. We have looked at the query analytics part where you have query details and query performance information. The next is advisors, which is basically intelligence built in PMM, where we have some pre-configured checks coming from our database experts. Whenever you add a database to monitoring in PMM, it runs those checks against the databases and tries to suggest you or give you a suggestion in terms of what you can improve if there is a change needed in the configuration or if there is a change needed in the way that you have set up your database. These are all coming from our experts. So how can you use this feature in PMM is pretty simple. I am using a very basic instance without any custom connections. So I will just quickly show you. As you can see on the home dashboard, there is 0 advisors, failed advisors right now because I have not actually executed any advisors check. In PMM settings, you get to change the interval of an advisor. So ideally they would run once in 4 hours. That's the frequent interval and the standard interval and rare interval. For the demo purpose, I'm just going to change it to the bare minimum value. Once I enable advisors, so here what you can see is there are some configuration advisors that we ship with PMM, and then there are some security advisors. What are configuration and security advisors? These are basically, for example, if you have a database that's outdated, you would get an advisor for that, a check running on your database and trying to tell you that you probably need to upgrade your database version. If you have a security configuration that probably is not done right, maybe like a root user without password, or if you have a CVE on the version that you're running, it's basically going to show you those advisors. Depending on your depending on your account, so we have Percona platform, where basically you can connect your PMM instance to Percona platform and get access to more advisors, custom advisors. And if you are a paid customer, it basically gives you even more advisors running custom for your deployments. So let's see if I am able to get some advisors on my database instance that I have just enabled. Ideally, it's not really needed to manually run it. It automatically triggers, but for the sake of time, I'm probably going to run it manually. Yeah. As you see, I just triggered the advisors, and I can start seeing them on the home dashboard. When I click on it, I can see that there is a check for Postgres CVE, because I intentionally set up a version that had a CVE, and I also installed an older version of Postgres because I wanted to see if there was going to be any warning on this or not. If you go back, probably we'll have more advisors showing up. Yep. You can see here that there are different checks that are basically being executed. Um, let's quickly jump on to the next part. So let's look at how backup and restore works in PMM. As I mentioned earlier, we have support for MongoDB backup and restore, and we also have support for MySQL. It's in technical preview right now. For setting up backup and restore, you all you need is to have PMM client installed on the host where you're running your database, and you probably need PXB and PBM depending on the kind of database that you're running. So if I have to show this on the instance that I have, I'll just quickly show you folks how it looks like. So before I prepared this instance for the session, I added a MongoDB replica set to my PMM instance for monitoring. I can see that on maybe. Yep. So you can see that I have a MongoDB replica set running right now, and I have metrics coming for that instance. What I will do is I'll go to backups and create a backup location. You can configure it using an S3 location, or you can do it via local storage option. For demo, I will just do a local storage. So configure a test location. There is a way for you to configure schedule backup for your database. We're not going to go into the schedule part, but I'll just quickly show you an on-demand backup that I'm going to take right away for my MongoDB instance. Choose replica set one. We have support for physical and logical both. I can choose the location that I just added. In advanced settings, you basically get to define if there was any failure, do you want to retry and stuff like that. So as you can see, it's trying to take a backup. You get access to the logs. If there's any failure, you probably want to see why that backup failed. You can get that access here. And as it succeeded, I can even restore from any specific backup. I currently don't have any restores on this, but I will quickly show you how restores look like. Cool. So that's how restores and backup work in PMM. you can access the logs and try to troubleshoot if there is any failure on the backups. Finally, going to the last part, which is database as a service, where you can actually use DBaaS in PMM, where you can provide it a Kubernetes config file, and it's going to install Percona operators on your Kubernetes infrastructure and allow you to deploy different DB clusters on it. I've got a sample Minikube that I have, and I'll quickly show you how that looks like. So for running DBaaS in PMM, you go to the DBaaS option, and there you see register a new Kubernetes cluster. I have a Minikube kubeconfig file. Probably my Minikube died. That's why I don't like live demos. But yeah. Um, Yep, I had another Minikube file that I was going to use. And as soon as you register your Kubernetes cluster, it will basically set up operators on it, and then you will have an option to create DB clusters. Um, Let it register and install operators while I will quickly complete the presentation. So there are some reference material that you can use and probably reach out to us if you have any questions while you're trying PMM. We have a Discord group and we have a PMM channel there. You can actually visit us and ask any questions that you have while you're trying out PMM. I am ready to take any question and answers if there are any. Yeah, please.
Of PG start statement and the PG start monitor you mentioned about?
Yep. So basically in PG-stat statements, we have a lot more metrics when it comes to CPU, memory consumption, histogram, all those we have in PG-stat monitor, while you don't get in PG-stat statements. Along with that, it's efficient as compared to enabling PG-stat statements on your Postgres instance. So that's basically the difference I can.
Maybe I would like to know where these backups are getting stored. Like, is it on a PMM server, or we can integrate S3 or external?
You can
storage.
integrate an S3 storage, and you can also have a local storage option. The one that I showed was basically getting stored on the locally on the client node. I don't know why I'm not able to register the Kubernetes cluster, but I'll quickly run the demo that I have for DBaaS so that you folks get an idea of how this looks like. I always keep a backup of video. So yeah, any other questions meanwhile? Yeah, it's completely open source. You can get to see the code that we have for PMM ManageD or PMM Agent. You can contribute back. It's completely open source. So as you can see, this is how basically the DBaaS looks like. Once it registers the Kubernetes cluster, it's going to show you an option to create DB clusters after provisioning it. And from there, you can actually set up different versions of the databases. As you can see, for MySQL, what specific version of database you want to deploy. For MongoDB, what version of database you want to deploy.
That's all the time we have today.
Okay.
But I'm sure you're around for the rest of the day. Please forward all your questions to him. Thank you very much.
Thank you. Thanks a lot for attending the session.
Ganesh? Okay, we are good. We can start. Welcome back, everyone. Today we have from Grafana Labs, Ganesh. He's a senior software engineer at Grafana Labs based in India. And he is going to talk about lifecycle of a sample in Prometheus TSDB.
Yeah.
Over to you, Ganesh.
Yeah, thanks for the introduction. Can you hear me loud and clear? Yeah, I think the mic placement. Yeah. So, in addition to what he gave as an introduction, I'm also a Prometheus team member, and I maintain the Prometheus TSDB upstream. So that's why I'm speaking about it here. Before we go into the TSDB, what is Prometheus? Prometheus is a metric-based monitoring and alerting stack. You can instrument your application or run exporters which will expose the metrics that you want to monitor. And Prometheus scrape, collect those metrics for you, store it inside, let you alert based on conditions. So it's a whole monitoring stack. And talking about the time series itself, it has an identifier. In Prometheus, it's just a set of label names and label values, like a pair of strings, you can say, a slice of pair of strings. The HTTP request total here is an example where the metric is tracking the total number of HTTP requests done for this particular job, and that one is a special label name which has a custom label name, and that's just a value. Along with an identifier, time series is just a stream of samples. Here, a sample is a tuple of timestamp and a value. We use Unix timestamp, and the value can be a float. And that's the basis of a time series which we are going to store in the TSDB right now. So Prometheus is huge. It does a lot of things, but we are only going to focus on the time series database, which is inside Prometheus in the middle, how it stores the data in its raw form and just makes it available for queries. So we are not going to worry about anything else that Prometheus does. So here there is a TSDB, and the sample that we are going to talk is the timestamp is a 64-bit integer, which in Prometheus we store the milliseconds as integers because we found that's kind of enough for most of the use cases. And in case of value, it's a float 64 value. So Prometheus right now supports more than float 64 custom data structure to store high resolution histograms. But for the sake of this talk, we are only going to talk about sample having 64-bit integer and a 64-bit float value. So before diving into how it stores inside a TSDB, we can look at the overview. So there is a component called head block. It's a component which stores the index of the recent data in the memory and recent data in the memory and some things memory map. We will see how it works in a moment. So this is the component that first gets the data in the TSDB. And after the head has stored data for some time, we create persistent blocks, immutable blocks which you can store for long term and do queries on it. So we are going to go inside this block itself and how they are created. So let's first look at writing a sample inside the head block. So here is the head block. There is nothing inside right now, and we get one sample and we create an index entry for this particular set of labels called a time series. Chunk is a compressed set of samples. We call it a chunk. In Prometheus, we use something called Gorilla compression by Facebook, and every time you get a sample, you compress it in flight and store it there instead of storing the raw samples. But before we put sample into the TSDB, we have first created the series entry in the index, and then we write into something called write ahead log. We'll see why it's required right now. Once we write it into the write ahead log, like log that this write has come to the TSDB, we then write it inside the TSDB in a compressed fashion. And inside the write ahead log, if it's the first sample, we store the labels of a series, and series gets an ID, let's say ID1, and we write another record which says the sample is T1, V1 for ID1. Yeah, it's the write ahead log. It just logs every write that comes to the TSDB. So we need write ahead log for durability. Just imagine you did a write request to the TSDB, and the system kind of crashed right now. Or you said to the upper layer that, okay, this write was successful. But if the system currently crashes, all the data is in the memory, how you produce it back. So we use write ahead log to replay the events that happened as is in the writes and recreate the in-memory data structure that we had before the crash or even during restart. And we get another sample we write it to the write ahead log and then the chunk. And inside the write ahead log, now you see we don't write a series record because we have already written a series record and you pass through it from start to end. So we just say for ID1 we got another sample. Yeah, that's about the first step of adding samples in the Prometheus. So let's say you added more samples and it got full right now, like you have to cut the chunk somewhere. You can't just keep on growing the chunk. What we do here is once a chunk is full, in our case we take it as 120 samples, but we are currently trying to cap it at a certain size as well. We just memory map it into something called head chunks. Head chunks are just a bunch of files where you fetch this compressed chunk and just the reference of that particular chunk, like where it's on the file in the memory. So you're not storing the compressed chunk in the memory. You are just holding a 8-byte reference, and whenever you want to fetch this series, you just take the reference, fetch it from the disk, and then query on it. This way, it saves memory for during majority of the time when you don't need to query that data. And the same process repeats. You get more data, more chunk gets filled. Okay, now you have a lot of data in Prometheus. How do you take care of it? Now we create something called persistent blocks out of the data that's present in the head block right now. We need to do that to make queries and a lot of things efficient. So this process is called head compaction, where we take the data from the memory mapped chunks which are on the disk, and also some data in the memory if it falls within some logic that Prometheus decides, okay, we want to compact data from this time range to this time range, and just create a block. And the same process repeats, we create another block. The earliest block, I'm numbering it n, the new block is n plus 1, it's like a linear set of blocks that come into the TSTB. Okay, but why do we need compaction? So time series are not always the same. After some time, you may be ingesting data into a new set of time series. So you don't want to hold index record of that in your memory. So once you compact and flush the data onto the disk, you use those index entries from memory and free up space. Also, you are holding the chunk references in the memory. That also gets cleaned up. And restarts will also be faster because now you have to replay less set of events to create the in-memory structure. Okay, so what about the bigger block? If you notice in the diagram, I have the n-2 block as something large block. It's we created from the smaller blocks that we just created. So imagine you have 4 blocks, A, B, C, and D. So based on some logic, we choose 3 blocks at a time and just merge them to create a bigger block. We'll see why it's required soon. Like every block has its own index, and we are going to look into the index soon. Yeah, block compaction is for efficient queries. It also reduces the disk space usage because the index is not repeated, and we'll see soon how. Yeah. So before we look at the block, at some point you want to get rid of the old data. You don't want to store the data in your system because sometimes you don't need the old time series data. So you can configure TSTB to have retention based on the disk space usage and also how much time range your data is covering. So this is an example of time-based retention. If we consider this as some kind of number line, every data which is beyond the red line, we have to delete it. But if a block overlaps, we can't partially immutable. We have to delete a whole block together. So once we add more data and create more blocks, and the block goes outside the retention range, it is just simply deleted. Like there is no waiting. As soon as new blocks come up, the old blocks goes outside the retention range. The data block is just removed from the system. Okay. So this is at a high level how TSTB works. Let's dive a little deeper into a block. So inside the persistent block, which is created out of a head block, it contains an index which maps all the data that's present in the block. It has a meta telling all the important information about the block, which will let you decide how to and when to query it. Tombstones for deletion, we'll come to it soon, why we need tombstones and why can't we delete the data from block immediately. And there is the chunks themselves. So we store all the chunks together in a bunch of files, all the compressed samples. Chunks are compressed unit of samples. So let's look at all of them one by one. Starting with the meta file. The meta file, like every block, has an identifier, which is called universal identifier, and block stores data from a particular min time to particular max time. So if you look at the meta, you know what's the time range this block is covering. Few helpful information like how many series, how many chunks, and if the block was created from other blocks, we also store the parent blocks for debugging purposes. Okay, now let's look at the chunk files themselves. This is pretty simple. It has a list of files. Every file is capped at 512 MB, and in every file we just store the compressed chunks as is, because all of this reference is mapped inside the index, and the reference is stored in a very simple manner. So we have a 8-byte reference for every chunk. The first 4 bytes stores the file number in which the chunk exists, and the last 4 bytes stores the byte offset in the particular file where the chunk exists. So if I give you a 8-byte reference, with the first 4 bytes you will tell which you want, and you will take this last 4 bytes and just seek your file to that byte offset, and there you have the chunk. The chunk has helpful meta informations to know how much to read at a time. So this is a simple way how chunks are stored on the disk. The most interesting part is the index. Prometheus stores index in something called an inverted index format, and we'll see how it's stored and how it's queried both. So at a high level, the index has 4 components. First is the symbol table. The symbol table stores all the symbols, basically the strings that were seen in a time series. The symbols are like, if you had label name HTTP request total, that is a symbol. Job equals to nginx, then job is a symbol, nginx is a symbol. So all the symbols are stored together in a single table, because if you repeat all the symbols in the index everywhere, it just takes a lot of space. So you just store it in a table in a sorted fashion and just use index. The first symbol is number 1, the second symbol is number 2, and just use those numbers everywhere in the index. So whenever you have to get the actual symbol, you look up this table. So this is the purpose of symbol table. And now the series itself. So it stores the labels that pertain to this particular series. Instead of storing the string itself, it uses the symbol table index right now to store which labels are for this particular series. And then a slice of chunk references. We saw earlier that chunk reference is just an 8-byte number, but with every chunk we store what's the min time of the chunk, what's the max time of the chunk, and what's the encoding of the chunk, so that we know how to decode the chunk. And the series are stored in a sorted fashion based on their label values, like sort first based on the first label name and value, then the second label name and value, and so on. So if you take S1 and S3, we know that if we sort it again, S3 is gonna come after S2 and S1. So this is how series is stored. These are just simple plain information that's stored in the index. Now we come to the interesting part. So in inverted index world, the postings are nothing but the series. Okay, I skipped one part here. So every series has a reference, S1, S2, S3 that I'm mentioning here. So those are again byte offset in the index. So if I give you a series reference called S1, you just take a offset in the file with S1, and there you get the series. In Prometheus, we align it to 16 bytes. So reference is actual byte offset divided by 16, and if I give you a reference, you just multiply it by 16 and get the byte offset, and you directly go to the series where it exists. And postings are nothing but those series IDs. So postings are series IDs, and we store a list of posting list. We'll come to it in a second why we are storing a list, but this particular section stores a list of those series IDs, and the reference PL1, PL2 is again the byte offset in the file. I'll come back to this again after looking at the next stuff. So there is posting offset table. This is the important part. So you saw every series has a set of label name and label value pair. And when in this posting offset table, we store like, okay, foo1 equals to bar1 is present in a set of series, which is represented by the posting list 1. And foo1 equals to bar2 is present in this particular set of series. So this is how we store the inverted index. For every label value, label name and label value pair, we store what are the set of series that correspond to this. this just points to a posting list as a reference, and based on PL1, PL2, PL3, we can look at this table to actual set of series that are for this label name and label value. So now we will see how we use the index to query. So let's say now I want to query in Prometheus fashion. This should fetch series that has both the labels foo1 equals to bar1, foo2 equals to bar3. So we take one matcher at a time. Let's see, we look at foo1 equals to bar1 and foo1 equals to bar2 against the posting offset table. Okay, now we know it matches a particular set of posting list. Now we have the reference where the posting list exists. Now we take the reference, look at the postings table, and we get the set of series references that actually match these label values. And now that we have two sets of series, like series references, you just intersect them, and finally now you know that this series mentioned by the reference S6 and S22 matches the query that you gave. This is a simple query that you can do on TSDB. And now you have S6 and S22. You just take those references again and look at the series table, and now you get the series. And the series now tells you what are the chunk references that you have. And then you can just fetch the chunks and do the query on that. And depending on the time range that you have queried, let's say you have queried from T1 to T2, you just trim the chunks when giving back to the API caller. I'll go back to this diagram again. So in short, we started at posting of, when querying, we started at posting offset table. With that information, went to the postings. From there, we went to the series, and we finally got the data. Okay. So when you have to, this is about querying a single block, like the index is concentrated on a single block. When you have to query multiple blocks, you do individual queries to each block. Even the head block gives the same interface of giving the label name and label values and get the samples and series pertaining to it. So there is just an implementation called querier, which queries each individual blocks and then merges the data together. Yeah. So this is where the big block comes in to help. If you have less blocks, big blocks, look up less number of blocks to get the same data. And because the index series, because sometimes series stay for a long period, you again deduplicate these entries. So that's the use of having a bigger block. And it's not just the equal matcher that is to be used. You can also do not equals to, or you can match a regex, or you can say if it does not match a regex, just give me these results. Yeah. So finally, we come to the tombstones. Tombstones are there to record the deletions that you make on a block. Because the blocks are immutable, if you have to delete a data and series, you have to recalculate the entire index because all the offset and everything is calculated based on the byte offset. So that is very inefficient. So when you get a deletion request, you see which series it affects and what's the time range the deletion is asked for, and you just record it in a file called tombstones, which just says for this series reference, this time range is deleted and so on. This is usually small, so we don't really optimize stuff here. And whenever you're querying, when you are looking at the chunks, you also cross verify with tombstones and only return the data that does not overlap with these tombstones. Yeah. So we have like 6 minutes, so I'll quickly cover a couple more things. We talked about head chunks that we maintain in the in-memory database part. We have to see how we replay it on startup. And there is another artifact called a snapshot on shutdown, which kind of helps in this replay. We will see in a moment. So when we are replaying the data, you first replay all the head chunks, basically the compressed chunks that you have on the disk. And once you have that, you replay the write-ahead log. Like when you are replaying the write-ahead log, decompressing the write-ahead log takes roughly half of the time, and then actually ingesting into the TSDB takes roughly half of the time. With the help of the memory map head chunks, we can discard samples which already exist in the compressed chunks. So that saves quite a bit of time. But still replaying write-ahead log is a little slow. So there comes a snapshots on shutdown, where everything that you have to replay on a startup, when you're shutting down gracefully, you just take a snapshot of that. You take snapshot of all the series that exist instead of taking it from the write head log records, and then take the snapshot of the in-memory chunk which has not been flushed to the disk. In which case you don't have to go to the write ahead log. You can simply skip the write ahead log, just replay the head chunks and snapshot. This way you can speed up the replay. And there are another component called write behind log, which is used for out of order ingestion of samples. The process that I showed right now, every sample has to have a timestamp greater than the previous sample for the particular time series for the compression to work well. So there is, for out of order ingestion, we have another artifact, but because of time crunch, we are also not discussing that. Yeah. And this was a very brief introduction. In 25 minutes, you can only explain so much. So I have a 7-part blog post which explains everything in detail. So if you want a link to slides, you can scan the first one. If you want the link to the blog post, you can scan the second one. And hence, thank you. So we have 4 minutes for Q&A.
Do we have questions for him? Wow, that was
it was very clear.
well received. No, but I was quite intrigued. I have never seen actually TSDB structure before. Head logs, which is a very common idea, right?
I would like to add one more thing, like this TSDB block is not just used by Prometheus. There are projects like Thanos, Cortex, and Mimir, which are distributed time series database built as an extension to Prometheus for long-term storage. They use this specific block format to store their data. Like they literally use the TSDB code. It's open source, it's Go code. They literally use the code to create the same kind of blocks, and they have some kind of superpower in the sense that the blocks are distributed. In Prometheus, it's all on a single machine. In Mimir, Cortex, Thanos, it's distributed, so you can when querying multiple blocks, you can just run a query on a separate machine, and that way you can speed up the queries. So this TSDB block format is used by multiple popular distributed database as well.
Any questions? Going once, going twice, gone. Well, thank you very much, Ganesh. It was a very, very nice topic, and thank you for sharing everything about Last leg. Come on, let's push on. We have a very good topic up ahead for us. It's about distributed PGSQL database. We have Saranya Sriram from Microsoft Azure Cosmos DB team, and she is actually from Singapore. So I don't have to welcome her, but take it away, Saranya.
Thank you so much. Hi.
Mike, you'll have to put it on. Mike, you have to put up. Don't put it on the lanyard. It creates a lot of noise. It's easier.
You can hear me, right? Anyway, okay. Thank you for having me. Let me introduce myself really quickly. I'm Saranya. I lead the product on the Microsoft side called Azure Cosmos Database. It's a NoSQL database. But today I'm here to talk about one of the companies that we acquired a couple of years ago. It's a startup specifically called the Citus database, if you've heard of it. We continue to keep it open source, and most of our team is supporting the Citus core engine. It is platform agnostic, meaning you can run it in bare metal, you can run it in multiple clouds. Just to kind of clarify the synergy of why Microsoft or my team acquired Citus is to also have the ability to provide distributed Postgres as a hyperscale service, say as first party in Microsoft. But for today's session, we will be talking 100% about the technology piece of the thing, which is essentially how interesting it is to distribute PG SQL using the Citus engine. Yeah. With that, I wanted to kind of just start off with a quick overview for how many of you have heard of Citus here? Okay, not bad, quite a bit. Thank you so much. Essentially, I think I've spoken or I've worked with the co-founders and the founders of the Citus engine when it became, for example, part of the Microsoft family, but also very passionate group of founders who want to and who are committed to keep this open source, and it will continue to be so. There were a couple of caveats of how, what problems Citus was trying to solve, and also why, for example, choosing Postgres as the base to start a distributed sharded, like a distributed SQL engine for extremely real-time analytics and fast query pushdowns and enabling at-scale scenarios, right? So firstly, wanted to kind of call out that the Citus is more like an extension over PG. So essentially, we will see that anytime there's a new upgrade on PG, the next day, Citus will be supporting the latest version of PG. So that's the promise that we provide on the release pages. And this will be fully open source and provides you multiple self-managed environment setup for PG. Also, just if you're curious, this logo that the Citus team came up with is to kind of say, hey, we'll start with Postgres, the elephant out there, but we'll bring some magic into the elephant like a unicorn. So it's like trying to bring sharding in terms of various kinds of tables on it. Also wanted to kind of call out where we are, and these links and all of them will be provided. We do have, for example, if I quickly try to take you to 2 links as we speak, and those are your landing links for this conversation. Today's citusdata.com, and the other one is where the releases are deployed. And we'll see the latest one is 11.2, and every few months you'd say that it's a standard stream of releases, and we can see that there. And similarly, the Citus data page on getting started, the main value prop of distribution and scale, parallelized performance, using Postgres as the base storage engine in terms of the way it's used, open source, and fully managed database service that can be deployed individually and simplified architectures. So just wanted to call out on that before we proceed. Setting context here, when we look at modern database platform, like to think of it as explosion, expansion on 3 pivots. One is the data structure itself. We started off like decades ago as structured databases, and from structured databases and in the last 10 to 20 years, NoSQL databases have come up big time. And then the NoSQL databases providing geo distribution, scale and shard, but then query performances are still the best when you say in relational data stores. So how can I get more ACID compliance in NoSQL base where we transition to what we call as new SQL data stores. But then if you look at SQL world of things, they've also improved. They are also supporting stores like JSONB and various other kinds of data structures, but also enabling query pushdowns and sharding, and that's what they call as DSQL or distributed SQL. So it's a merging of DSQL and NewSQL world, and that's where, for example, Citus engine is providing strong query language in terms of relational database of Postgres, but also being able to provide that kind of shard, right? So that's variety of data. The other thing is volume of data. Data is very cheap to store, and the compute on the data is what is more expensive, but data itself, GBs to TBs to, in fact, petabytes of data is something that Citus, we have 1 or 2 customers on Citus who are using that. So it's really the volume of data that's expanding and the velocity at which they are working as well. So starting from batch operations to transactional workloads to real-time analytic workloads, all of these need data to be accessed in specific formats, right? So multiple questions that we asked when, by the way, I'm speaking on behalf of the Citus founding team, the ones who have been contributing to the source code, etc. I joined late personally into the bandwagon, so I'd like to be more like a messaging folk to that. But then the key detail on which is how can I solve problems of scaling out of data, performing various kinds of queries on data, could be transactional queries, could be real-time analytic queries, could be batch queries. Essentially, systems have become what we call as HTAP systems, hybrid transactional analytical processing systems, and how can today's workloads bet on that, and the data structure on how you're trying to store the data. While these are being said, now on which Citus has been built in terms of core benefits of PostgreSQL. So in terms of the extensions has been something that probably has been the singular most important thing why Postgres has been adopted so widely by the community, as opposed to forking and setting up your new data store. How can I build on and then build extensions on it is something that has been valuable. Data structures such as JSONB, as I said, has been pivotal in terms of being able to query and also being able to distribute. So geospatial data. So all of those are the tenets, rich indexing, of course, the query and query pushdown. These have been the search, index, extensions have been the pivotal of PG, while we look, for example, in terms of scale out, in terms of global reach, security components, HA that has been built in, there is options to have high availability and replicas out, running queries and running queries that can be more intelligent, integrated, etc. So those are certain things, right? So the other thing is when we look at Citus extension for Postgres core benefits, we are looking at 4 main pieces. One is scale out horizontally, as we said. Simplified infrastructure, where you can decide the number of nodes we want, and then how the system sets up, performance, and then like literally one day in terms of catch up, in terms of the existing PG version support as well. What are probably the key differentiators when it comes to Citus? Right? So today on Citus, you can start with a single node, for example, and in place without downtime, you can scale out to multiple nodes. So that's an interesting thing. And when we say as a single node, there are 2, 3 interesting constructs. In fact, just 2 simple constructs on Citus. One is called the coordinator node, but today at least everything is piped through a coordinator, single point of failure if you have a single coordinator node, so to speak. But from the coordinator, which has the metadata store, you have multiple worker nodes where you can decide how your data needs to be sharded, and then the worker nodes actually contain the data. Right? So if you have a single node, then the coordinator and the worker and all the shards essentially sit on a single node, and then you can have scaled out to multiple nodes, what we call as shard splits, and non-blocking shard splits, meaning the incoming queries can be allowed to, without blocking any active workload from coming, and the backend shards can be, worker nodes can be split out as well. So that's something that in terms of online scaling. And the other thing is called online rebalancer. These are issues that people see, we see a lot, for example, in the NoSQL world that I am more familiar with, for example, where just the laws of the physics and how your data has to be stored, partitioning in a geo-distributed space is completely given, so your data is sharded. Now, once your data is sharded, and you shard based on a particular shard key, and the shard key could be a single property or a single value, could be a compound key, could be a nested key, could be a hierarchical partition key where you have one shard key and then multiple other shards as sub-partitioning, so you have these options. All of those are things that you're probably familiar, or it's there in other services in today out there. But what is interesting is how in an active production workload can you avoid hot partitions, or can you avoid shards, some of them which are hot while others are very cold. And for example, you don't have a, for example, including Citus and in other databases as well, actively you don't have a hot and a cold tier in terms of storage or data. And for you to run a query saying run this as a hot query, run this as a slow query, which means the query can go to a more cheaper storage, or the query has to go to an in-memory storage. Like in terms of the query pattern, that is not very common if you kind of think. The other option is actively real time, assuming that I have all my data that I need. Can I rebalance? Can I remove components from one shard, includes data movement, and move it to another shard? So in Citus, this shard rebalancer distributes shards, the old and new shards, so the worker shards are balanced. And the best part of it is it gives you granular control, as you as a DBA or a developer can actually say, in fact, you can say, I wanted to move from this particular shard to another shard. One example of that is this tenant isolation. So for example, there are commands, like you can say isolate a tenant to a new shard, and you provide the table name and the tenant ID. In this case, a new tenant has come out in shard 4, and we want to say that, hey, I want to separate it into an entire new worker node and then have this single tenant into that. So the difference is, and in fact, if I, coming from my NoSQL hat, if I look at that, there are systems wherein this happens automatically. While it happens automatically, could be an extremely cool engineering problem for us. Say, I talk from Microsoft, for example, for us to solve, to say in a multi-tenanted system how we can do that. We actually see a lot of customers saying that, hey, we know our workload the most, and so we want to be able to say which is that large tenant that needs to be isolated. So systems like Citus actually provides that granular control, and that's something that is very much valuable there. The other thing when I say key differentiator, it's like the next day availability of the open source PG version that's available will be available on Citus right there. So next we talk about the high level architecture of how the Citus extension works. So essentially a PG client would hit the coordinator node. The coordinator does not contain the actual data. It contains mostly metadata, and also there are something called local tables that you can say can reside only in the coordinator. So it contains fair amount, less amount of data, but mostly the routing patterns to say which worker nodes have which shard, and so it can route the request and aggregate the request part to create parallelization. So that's the coordinator, and then you have multiple worker nodes depending on, again, the user's choice to say I want to have 2, 3. I can even do a 4-core machine and scale it to 6, 8-core in place, or I could be able to fork it out and say I want X number of worker nodes. So next, when we talk about the coordinator nodes, I said it contains node with metadata information typically used for routing. So in this case, in this sample, you kind of see that there are multiple worker nodes, 4 of them here, and each of the worker nodes can have X number of shards, right? They could have various number of shards. Now, the interesting question is, how is the shard decided? And in case of PG, for example, say a PG, a database has some 50 tables. Now, all of these 50 tables need not sit in all the shards, for example. So there is the way we define it, for example, I would want to just go through a small example here, like how do we take an example. For example, I'm having a sales transaction here. So a local table, when I say create a table, local table is created, which has sales transaction ID, the customer ID, date, and amount. Just an example that we're just sharing. And then when we say create a distributed table, and then I'm giving it the customer ID as the shard key, and then I'm saying I want this as a sales transaction table. So create a shard on this customer ID. So you will see that all customer IDs 111 will be considered as one shard, customer ID is 112. So all the sales transactions for one particular customer will be stored as a single shard. Now, what is interesting is the 3 kinds of tables. I'll come back to this, but I want to just talk about this so we understand the architecture. There are 3 kinds of tables. This table that we saw here, this the sales transaction is what we call as a distributed table. That means this table exists in every worker or the subset of workers. It is sharded table. That's a distributed table. And for the distributed table, you need to have a shard key on which it distributes. Typically, if you make a query based on that shard key, then your query will go only to those worker nodes which have that shard data. For example, if there are multiple tables, but all of those tables have that shard key as their primary key, then your query is the most efficient because it's just going to go to those shards in that particular, a single worker node or maybe a couple of worker nodes to get the data, and all the multiple tables which are sitting on the shard key for the respective key ranges will also be co-located with each other. So that is your distributed table. Reference table is a table where you feel that I don't have an exact partition key or a primary key on which I can actually map 2 or more tables. So I want the table to be there in every single worker node. So situations where I know that I need the table to be, again, like a copy of the whole table to be stored, I store it as a reference table. And the local table is typically the ones that's stored in the coordinator node for a specific kind of joins that you want to do. You have some sort of a you have a product catalog and you say I have these 5 items that are always going to be there, or I want to merge it for a particular campaign and the campaign will go. I can store it as a local table, merge it, and once the campaign is, I can drop that local table or things like that. So that is the high level there. And the other thing is how are queries routed. So that's what I was trying to just say it at a high level. When you write any query on the Citus engine, essentially, so query is typically what we say is we would say we want the query based on the shard key. The query will go to the coordinator or the node, and then it will be routed. For example, in this particular case, will be routed to that particular shard which has that data. Now, if the query has joins or query has multiple tables, and there are 2 scenarios that can happen. One scenario is the shard key is the same shard key in those multiple tables, then actually the way the system is sharded is such that only those respective co-located data ranges is actually showed, which means you'll have lesser number of queries to be made on the worker node. 2 is the option to use reference table or local table. So that's 1. 3, otherwise the query will actually run to specific worker nodes that have, and that's kind of the more worst case scenario or the situation where performance wise it's probably not the best. The couple of other use cases in terms of what we wanted to cover in this session. One was just highlighted 4 main use cases. Real-time data analytics, mainly because we say real-time analytics means that you want a better kind of query which includes some smaller aggregations, query includes some real-time data and stronger query pushdowns. So it helps to have Postgres engine for that, and we see Citus better there. Enabling HTAP, where the same engine can be used both for OLTP and OLAP workloads. IoT-based telemetry systems because of the real-time nature and lot of situations which have lot of concurrent needs tend to be better off in the Citus because they parallelize workloads better. And then definitely huge customer base and adoption I'm seeing in the multi-tenanted SaaS workloads here. So when we look at real-time or time series operational analytics in terms of reporting, here's so the diagram which is there just put in a lot of the customers that I have seen, which includes a lot of Microsoft based workloads, such as you'll see Databricks hosted on Azure Databricks. This could be any kind of web app service, could be any push notification service like APNS, GPNS, in our case NPNS, which is Microsoft Push Notification Server, any eventing systems, so on and so forth. But essentially, as you see, there are 2-3 things that is interesting. The Citus engine enables what we call a spread out, shard out, etc. And hence we use the word hyperscale. But in the true sense, when I say hyperscale, you probably want some cloud vendor to maintain that hyperscale for you. But there are people who actually take the open source Citus to be able to set their hyperscale clusters also. So that is very much possible. Freshness of data availability, durability, concurrency, all of those are obviously the most important pieces. Choosing the shard key is probably the most important decision just as we do that in any NoSQL components in Citus as well. So that's important. Then scaling multi-tenanted SaaS applications, as we spoke about, and there are some interesting pitfalls. IoT as well, just go over that, purely IoT workloads and considerations, high transactional analytical workload considerations. So those are the big things that we want to talk. And just to close off today's session in the interest of time is some of our large customers, for example, open source Citus have about petabytes of data sitting through. There have been situations where suddenly when we have huge number of workloads, like concurrent users, 60,000 to 100,000 users, something that Citus scales. There is a Citus Con, which is coming up this week, actually, April 18th and 19th. I wanted to close today's session by saying that this is purely based on our open source Citus engine and our contributors who are founding that. Pretty interesting sessions available there. Things around efficiencies of shard rebalancers, other extensions on PG, high availability being baked in, so on and so forth. So with that, thank you. And if there are any questions, happy to take.
Do we have questions for Sharanya?
Hi, Sharanya. So the data model itself needs to be changed from an existing Postgres database to be adopted into hyperscale.
Actually, it's a very valid question.
So, sorry. Do you see any intelligent solutions being built at Citus which helps in bridging this gap?
So long story short, I would say schema migration is not an expensive affair, or it's not something that is needed 100%. When we say moving from relational to NoSQL, there is an entire data modeling exercise that's needed. Whereas existing PG to PG Citus, there are 2 kinds of activities needed. One is based on what is the main query patterns and whether I have a right shard key on those query patterns. And 2 is how is my data exploding or expanding, or what is my elasticity needs. And so based on those 2, there seems to be some tweaks, but essentially if you have, for example, 20 tables on Postgres, you have the same. You have, so the overall all extensions will be equally supported. Similar foreign key, primary keys can be construed. So I would say that is, that's there. It's not a problem. But we don't have a ready-made tool, if that's your answer. We have to work on building something.
The shard rebalancing, is that part of Citus or is that part of the cloud service?
It's part of Citus. It
Part of
provides.
Citus, okay. Thank you.
The latest 11.2 provides shard rebalancing.
Yeah, hi. I have 2 questions. The first one is just now it says it has parallel processing. So does it mean that if I run a query across multiple shards, so it will do a MPP on all the shards?
Yes, it will parallelize your, so if you do your query on multiple shards, it will spin off separate threads and it will run the threads on each of the shards. It will reply, the coordinator will aggregate back and respond. The upcoming version on Citus is going to parallelize the coordinator. That is not yet available, but that's coming up.
Sorry, we are really out of time. We need to have our next speaker.
Thank you so
Chinvi?
much, but I'm going to be there here.
Chinvi?
And I will
back on track. We are about 3 minutes behind, but we should cover up. We have Chinmi from Grab to share. I mean, it's a very long title, probably one of the longest I've seen. But she would be talking about data modeling. So let's get started. Chinmi, over to you.
Okay, can you hear me now? Like this? Okay. You know, first time speaking in person after the pandemic. Like this. Like this. Yeah. Okay. So you can hear me. Okay. Yeah. Maybe. Yeah. Yeah. Okay. Okay, so hello everyone. It's nice to be in person again. I'm Chin Hui, and today we're going to be talking about like how do you model data fast, going back in time using dimensional modeling in a modern data stack. So as you can see, it's about being change aware when you are doing your data modeling. Yeah, so about me, I currently serve as a senior data engineer at Grab. So I am a technical speaker and an occasional writer on data engineering topics. So you may have seen me around on some of the blog posts or in the Pi Data talks. And I am 90% self-taught because, as you can see, where the 10% actually came from. It comes from my engineering degree. So my engineering degree actually comes in very useful here. So before we begin, some disclaimers here. Well, everything in this talk is based on my own technical expertise. There's nothing to do with my team or my employer. So it's pretty much like my personal experience based on hard-won battles. And the scope is primarily focused on structured tabular data. So I understand that for data versioning, that we have structured and unstructured data. So it's similar concept, but the focus of this talk is on your structured tabular data. So let's imagine this scenario in your data team. So imagine that finance department requests a regen of your report dated 11 months ago for client A because it's year-end regen, right? So we need to regenerate the reports. Okay, so client A has already been upgraded from a tier 2 customer to tier 1 customer 3 months ago. So if you are sort of promoted in your tier, that you increase your earn rate. But the problem is that you do need to regenerate the report based on tier 2 earn rate because client A was tier 2. So you can't really generate it based on the fact that he's a tier 1 customer because he wasn't. So this is what the data will look like in this scenario. Now, when you are at some point in time, it was, so you can see that client A was a tier 2 customer. But then, like, when you're trying to regenerate a report by the end of the year, it's already a tier 1 customer. So what happens if we regenerate the rebates report for 11 months ago at the end of the year? And now that your customer tier actually has been updated and overrated. So what do you do in this instance? Because you can't find the data back, right? So this brings me to the concept of time in dimensional data modeling. So time is an important dimension in your data because the data is usually not static because you can have state transitions during a business process and your attributes can also change over time, such as your age, your income, your status, and in previous case, even your customer tier can change. So don't assume that your data is static. And this brings us to the importance of data versioning. So what is data versioning? Now, data versioning is the concept of capturing state changes while keeping track of successive versions of the data over time. So what it means is that for each data record that you create, you need to create a unique reference for this collection of data when those changes occur while you retain the previous versions. So there are two general data versioning approaches. So one is more for your structured data, which is what is known as change data capture. So there's also an extension of data version of this change data capture approach, which is applied to unstructured data, which is the concept of data version control for unstructured data. So for those who are not very familiar with data versioning, so this is what your change data capture and your data version control roughly looks like. So change data capture is what we are quite familiar with, the traditional approach of having your timestamps and having your valid from valid to. And for data version control, is more on like something like version control for data. So you have examples like like the iceberg, or you have your DVC and so on and so forth. So those are actually like extension of change data capture. So why does data versioning matter? So as we can see, one of the main reasons why it matters so much is because of reproducibility for data governance and audit purposes. Because let's say at the end of the year, we need to regenerate those reports, and we also need, and we do need to be able to capture all those changes of your dimensions over time, because we do need to be able to report to whatever authority it is, like meet your data governance team or meet your audit team, and you need to have an audit trail of like the changes in your data. Then number two is is to build data history with backward and forward compatibility. So this is more for the data team. Because what if there is a change in transformation logic that only applies to a specific time range? But let's say they say that marketing says we have a promotion for a specific time period. So we will need to change our competition logic for our rewards. So in this case, it's only for that specific time range. And you need to be able to capture this type of change in logic. And last but not least, this is a little bit similar to the first point, but it's more of the fact that when you need to use point-in-time values to track business metrics over time. So this is more in the case whereby if as the business user, they need to be able to have a good profiling of how, let's say, the customer profile actually changes over time. So they do need to have a good audit of that to be able to monitor their business metrics. Okay, so now we've talked a bit about data versioning. Now, what is change data capture? So change data capture is simply data versioning from databases. So those are design patterns for capturing and tracking changes in your data from your upstream source systems over time. And in this case, our changes are actually captured in either your data warehouses or data lakes. I mean, the differences are not very clear anymore because your data lakes are going to have your data lakes and your data warehouses they are data warehouses. Okay, so some design patterns for change data capture are firstly a data versioning based on a combination of the version identifiers, timestamps, and status indicators, which means that whether the record is valid or not. Another design pattern that's very common is your log trigger or tuple versioning, which is also known as type 2 slowly changing dimensions, which I will elaborate a bit on later. And last but not least is transaction logs. So transaction logs are specific to the system, so let's not talk about that. Yeah. Okay. So now I've talked about why the data versioning method, why it's change data capture. So now let's go on to the context of this talk. What do we mean by the modern data stack? So it sounds like a fancy word, but simply put, modern data stack means that it is cloud-based, built around the cloud data warehouse of the data lake, and is modular and customizable. So instead of the traditional approach whereby we choose a vendor and it's a one-size-fits-all, we choose the best tool for the best job. So if we look at the components of a modern data stack, you have your ingestion step, which is done by the data loader. You have your data, which loads data from certain upstream source systems to your data warehouse, and then we go through data transformation, which goes through, let's say we have the staging layer, when we have bronze, silver, gold. So this is also what we call the medallion architecture. And after we process it into the gold layer, this is subsequently used by downstream users, which could be for your machine learning, or it could be for data visualization. And those are orchestrated by Airflow, let's say a workflow orchestration tool such as Airflow. So So what about data warehousing in the modern data stack? So because we are using cloud-based compute and storage, this means that your compute and storage are now more scalable compared with your traditional data warehouses. And instead of the traditional ETL approach, we are now moving more towards an ELT approach, whereby the transformation is done within the data warehouse. And last but not least, the most important implication of this more scalable compute and storage is that it is now possible for us to store snapshots of data in a cloud data warehouse to capture all those historical changes. So this is something that may not be able to be done in the traditional data warehouse, whereby compute and storage is a blocker. And now we talk about what's the difference between a modern data stack and your traditional data warehousing approach. We go to the point about the change data capture in the modern data stack. So now we have this modern data stack. So what are the implementations that we have for change data capture? So we have the traditional Kimball's dimensional modeling techniques, which is mainly on the concept of slowly changing dimensions. And we now also have modern approaches such as using data snapshots and also leveraging on incremental models. Those are a little bit more modern and a bit more functional. So let's go on to this. Let's go on to all these techniques. So the traditional Kimball style dimensional data modeling. So for historical context, it's developed by Kimball in 1996, and it was quite updated with the latest update being in 2013. During the emergence of cloud data warehouses, that's where you have your BigQuery and your Redshift. And this is an important concept because Kimball introduced the concept of facts versus dimensions. And during the time when you have limited compute and limited storage, this data modeling approach is designed for storage and compute efficiency. And so let's go into the fundamental concepts of facts versus dimensions. So fact tables are okay. So what fact tables? Fact tables contains metrics and facts about business process. So it could be something about your process time or the transaction amount during the business process. And one of the defining characteristics of a fact table is that they are typically fast evolving during a business process event. But eventually, it will reach a final state at a point in time upon completion. So you know when it will end, when this process will end. So there is a definite end point. Dimension tables, however, they describe the attributes of a business process. So it could be your customer details. And they are typically slow changing and updated over a longer period of time because you don't, so okay, maybe you know that like your customer is going to be like age 30 like this year and age 31 next year, but you don't know whether your customer is going to upgrade from tier 2 to tier 1 or is going to get married or get divorced. So you can't really estimate when the dimension will change. And they typically do not have a final state per se compared with a fact table. And this brings us to the problem of slowly changing dimensions. How do we capture changes that are slow and unpredictable? Yeah, so okay, so we talk now we talk about slowly changing dimensions. Let's talk about the types of slowly changing dimensions. Okay, so what are slowly changing dimensions? So slowly changing dimensions are change tracking techniques to handle the state changes in dimensions. So you have the type 0, type 1, type 2, type 3, type 4, type 6, many types. But let's just go through the important types. Right, so type 0 is very simple. It's fixed dimension. So something like account opening date. So once you create it, you're not going to change it. So it ignores any changes. If you try to change it, it's not going to change because it assumes that this attribute will not change forever. Type 1, on the other hand, reflects the latest version of dimension attributes. And what happens is that when you have a new record and then you realize that this new record is actually related to to something that's existing. So the previous version of that value is overwritten with a new value. So great, we have updated the changes, but in this case, you have destroyed history because what if it is an erroneous update? It's not possible for you to rewind back to the previous version of the data, so that's lost. In type 2, which is the focus of this talk, it implements row versioning for each dimension attribute. So for each record, you have a concept. Each version of data, you have a concept of validity period. So you have a row effective date, you have a row execution date, and sometimes you may even have a current row indicator. So in this case, when the change is detected in the data record, instead of immediately overwriting the record, you create a new dimension row with the updated attribute values for the data record. And for that particular new dimension row, you create a new primary surrogate key. And then the previous version of the attribute is updated with the row expression timestamp. So instead of overwriting destroying history, you are updating history. So just now I mentioned about tuple versioning. So what is tuple versioning? So tuple versioning is change data capture mechanism that record changes to a mutable upstream table over time, and it implements your type 2 SCDs on a mutable table sources. And typically, it will detect change based on some updated at timestamp, but maybe the naming may change, but the rough idea is there. So some components is that you need to know where are you going to save your tuple versioning. You need to know where to track. You need to know what's the unique identifier, and you need to know whether to invalidate records no longer in source. But sometimes you may delete the record. So this is an illustration of how tuple versioning works. So we have some timestamp that we are tracking, and we are using that to determine the validity period of the record. So this is the initial state. And then when you see that there is an update in the customer tier from tier 2 to tier 1 at a particular point in time, instead of overwriting it, you capture the changes in this case. So now you can see that we have updated the validity period for the previous record. Okay, so we have the type 3, type 4, and so on and so forth, but we're not going to go that in depth into that because this is less commonly used and it's a bit more complex, so let's not. So you can read it on your own. Right, now let's go into the more modern topics. So data snapshots. The data snapshots are read-only immutable copies of the state of the data source at a particular point in time. And usually, you will store all those data snapshots at the staging area of data warehouse, whereby you ingest from the source and then you throw it at the staging area for further processing. So you can think of it as you're taking timestamp images of the data sources. So you're like taking photos of it at a certain period of time, and instead of directly creating your SCD tool, you are creating your data snapshots, and so that you have those data snapshots, and then you can proceed to create your FCD tools or whatever downstream data models that you like to create. Because in case you mess up your SCDs, at least you still have those data snapshots to fall back on. Okay, now to complete this discussion, we have incremental models because we need to capture changes in your upstream data into your downstream models. So the concept of incremental models is that you limit the data transformation to a specified subset of source data. So typically, you want to be able to capture those data that have been newly created or updated since the last scheduled run, because you don't want to do extra work, right? And in this case, not only do you not do extra work, you also significantly optimize your runtime on the transformation of the large data. So that's why you may want to use the incremental approach instead of a full load approach. Now, something like this. So it takes a bit of work, but you need to determine what is the incremental load that you would like to load. Because and it's typically what has changed since you previously ran your last scheduled job. You need to get the delta. And how it actually looks like in, let's say, your DBT models are, you typically define where do you insert the load, how do you insert the load, where do you get the load, and before you think about where do you get the load and all those things, you need to know like what do you do? What is the condition for this incremental load? Because otherwise, you're going to load the whole thing. So those are the thinking approaches that you need to think of when you are defining an incremental model. So if we are looking at an SCD2, it's pretty straightforward because if you're doing just an incremental load, you just need to select the most current records and just load it in. Yeah, so you can see it's just some like if you see that you can just look at what is the most current record and your job is done. Yeah. Okay, so some things to think about when you are looking about designing an incremental model is, does it already exist? Because if it doesn't exist, then you have to do the full load. Do you want to just is there something wrong with your transformation and you want to refresh the whole thing? Or things are fine, so let's do an incremental run. So you need to include those cases. And then what's the incremental strategy? So it depends on whether it's a data warehouse or the data lake. Yeah. And then some columns to track changes. So those are the typical things. Yeah. Okay, so is Kimball's approach still relevant? Especially in the modern data stack? So turns out it still applies because even though your storage and compute are dirt cheap, this doesn't really apply for very large dimensions because your storage and compute are not going to be very cheap in that case. And this does not preclude the importance of dimensional data modeling. If you kind of find out more, you can read his blog. We can read the Maxim Butcherman's blog posts and also watch his talks about that. Yeah, and in some way, and it doesn't mean that we need to learn everything about Kimball because yes, in some ways you do need, and typically you will really need to do a dimensional data modeling in certain cases. So one case is when you need to aggregate facts, then yes, you do need to put in some work into how to model your data. Secondly is about metrics drill down based on dimensions. So that you also require some thought in how do you want to model your data. And last but not least, typically Kimball is still used in financial reporting and audit because this is where it comes very useful. You need to have an audit of your changes in data over time. So that is a requirement. So in this case, you can't say I don't want to do Kimball. You have to do Kimball in this case. So now to round up this talk, I'll share some tips and tricks on ensuring that your data modeling is change aware. So first tip is to snapshot all your upstream source data. Yeah, because you are now in the modern data stack, your compute and storage are scalable. And what if assumptions about your data change? So let's say your backend team tells you that it's an append only, but it's an override. So what do? If you already use an SCD2, I'm not sure how you're going to rewind your changes. So still, please save your upstream source data and snapshot them. And secondly, like you have all those things like, my columns are changed, my columns are dropped, I add some columns. So you still need to be able to have a photo of your state of your upstream source. And last but not least, it's about your business logic, because they can tell you that retroactively, hey, we need to apply some business logic retroactively. So you still need to have those copies of your snapshot to be able to modify your logic. And as I mentioned previously, store your data snapshot in a staging area and build SCDs from there, instead of having your SCDs directly reading from your upstream source. So in this way, if you mess up your SCDs, you still have your data snapshots to rely on. Yeah, and of course, speaking about schema changes, it's useful to detect your schema diffs to your upstream source and your data warehouse. So something like this, something like a source target schema reconciliation would be useful for you to detect changes. And use type 2 SCDs and incremental models, because type 2 SCDs are typically sufficient for tracking and capturing data changes. You don't need to go into SCD3 or 4 unless it's special cases. And you may think that, why do I need to think about incremental models? It's so complex. But when your data is going to 10 times, 20 times, 100 times, incremental way, it will pay off in terms of efficiency and cost. So unless you are like a startup and when you want to deliver fast, then you can go ahead with like iterating fast. But if you want to think of your data models in a more long-term manner, then it pays off to actually develop in an incremental way. And to round out the talk, some strategies on designing incremental models will be to design with upstream data update mechanism in mind, and also think about your incremental strategy because it depends on whether you're using a data warehouse or a data lake. And a performance tip is that you want to filter those early before you do any computation. Because if you do the computation first and then filter it, then it's going to be pretty expensive. And so some key takeaways would be to adopt a mixture of like SCD-like approaches and incremental models, and also data snapshots. So that's about it. So thank you. And you can get those slides with this QR code. Thank you.
Thank you very much. I'm extremely sorry we wouldn't have enough time for questions. The next speaker has to get ready as well.
Yes.
Thank you, everyone. We'll wait for the next speaker.
Okay. Yeah. Thank you so much.
Good afternoon. I am Umang. I will be presenting a talk on lip camera, making complex cameras easy. Good. Thank you. First of all, I want to thank FOSSASIA organizers for organizing the conference and in person. It has been a really weird time after a pandemic. I am Umang. I was basically a desktop engineer. Recently, I've turned into an embedded developer. I have been contributing to open source since a long time now. I have been contribution across GNOME OS 3, Flatpak, and other immutable OSs. Recently, I'm doing mostly embedded upstream Linux media and lip camera these days. So we'll first take an overview around what complex cameras actually mean, what are the challenges around in this field, complications, what we have been able to achieve, and finally, any questions, I would be happy to answer them. Just a disclaimer, there are logos and trademarks in this talk, and they belong to their respective owners. So we have no intention or desire to take over their work. So let us begin with complex cameras. This was around 10 years ago. The cameras were simple. You really had a sensor, and on the SoC you had either a CSI2 receiver or a scaler which will scale your images and just give you an output to the capture node. And the application could really work with them. They were simple to configure and to develop. But around, I will not name the model of this phone if anyone can guess it. Sorry? Yep. This is where the complex cameras got complex. Now, from the simple, from here we are here. The complex interfacing and the basic pipeline got very complex. In the red boxes, you can see how the raw sensors are present. On the SoC front, you might have CCP2, CSI2, something like AE, like auto exposure white balance, and a preview node for previewing the images and other nodes for the still capture, because preview nodes are generally low resolution, and for the still capture, you need the highest resolution. So they were separate nodes. And for the API configuration, you had multiple nodes like video 7, video 4, and their video 3, respectively, to configure and get the images out. So from the left-hand side, where we had a simple camera media graph, we went to something like this. OMAP3, Nokia 900, that's correct. Now, in the recent development, you might have also come across the Raspberry Pi autofocus camera modules as well, which, if you can see in the middle, the silver plate is basically a motor, a very small motor called a voice coil motor, which will move the lens to adjust the focus of the image. And something like the autofocus block will be somewhere here in the green. So it's yet another node coming up. You can see how the complexity of the camera and the pipelines is getting increased day by day. So what are the challenges here? From the application point of view, applications can manage to a certain extent, but the problem is that, it doesn't scale. You have an application and you have an underlying hardware. The application is very much tied to the hardware. It cannot be ported to any other hardware. For example, application written for Raspberry Pi cannot be ported to Rockchip, or cannot be ported to applications like more complex camera hardware like Intel IPO3. So applications were very tied to the hardware. Application developers would need to know the underlying hardware and how to configure it. There are multiple nodes, as you can see, and each node has to be configured in a certain way at a certain time and a certain position in the pipeline. You cannot configure, for example, the resizer node before the CSI2 node receiver and all of that. So this makes the application development quite hard. So lip camera comes up as a solution, or rather tries to be a solution, but let's see how it is filling the gap. So before we go ahead, I would like to show you an overall architecture of the lip camera, which might seem a bit complex at first, but really is the kernel where the drivers live and the underlying hardware. The kernel exposes a V4L2 API and a meter controller API. On the top, you can see the adaptation, which is like basically the application-facing APIs that the lip camera provides. The core is a lip camera helper libraries, and the pipeline is where things get interesting. On the top right, you can see the pipeline handler framework, which is very specific to what the underlying hardware is. So lip camera will have pipeline handlers for Raspberry Pi, different pipeline handler for Rockchip, different pipeline handler for IPU3 or IMX810 Plus, whatever the underlying hardware is. It will abstract all that inside a pipeline handler. In the middle, you can see in the red box, you have the IPA module, that is image processing algorithms. The image processing algorithms are the ISP blocks that are provided by the vendor. They are usually embedded on a system on chip, that is the SoC. Lip camera provides a way in combination with the pipeline handler to configure the IPA or the ISP that is present in the system on chip. What happens basically is, if you can see in the previous diagrams, the red nodes are basically the raw sensors. These are the sensors which if you cannot see a raw image directly, it needs to go through the processing blocks. So the processing blocks and the algorithms that run on the platform are encapsulated in the IPA itself. The IPA can be proprietary. We have customers where they don't want to open their IP, and all the business is driven by the IPA module being kept proprietary. So lip camera automatically has a sandboxed environment where it can plumb the proprietary IPA into itself and can run with the open source pipeline handler to get the images out. And when you have a camera, when you have written an application, lip camera can do the device enumeration. It can discover what kind of platform the application is running on. If it is a Raspberry Pi, it will invoke the Raspberry Pi handler, Raspberry Pi IPA algorithms, everything. If the same application is run on Rockchip, it can detect that it's a Rockchip platform, and accordingly the pipeline handler algorithm and the entire pipeline is configured in that way. So to summarize, lip camera, how do we define it? Open source camera stack and framework for Linux, Android, and Chrome OS. What are the complications? So basically, V4L2 is everywhere, and everybody seems to love it. It exists, first of all, in the upstream Linux kernel. There is no other, for the media capture, V4L2 is the, by default, API that kernel provides. If in future kernel comes up with a different video capture API, lip camera would be happy to support it, and we are working in that direction as well. The same APIs, V4L2 is used for simple cameras, digital TV, set-top boxes, etc. So when you have something like, there are areas of conflict such as color spaces, where some color spaces doesn't make sense for a camera, but does make sense for a TV or set-top box streams. So there are conflicts like that, but the V4L2 API is what we have, and we have to live with it for now, but it is widely tested. V4L2 is used already. It has great interoperability, and these are the applications and the media frameworks that you can see on the screen. But not everybody loves V4L2, because the problem is everything is configured through a node, and when the camera pipeline is very complex, the application has to take care of various types of node and has to deal with reconfiguration and configured in a certain way, which makes them quite opaque for portability reasons. Sub devices, as I said, like there is ISP on the system on chip. There are multiple devices that needs to be configured. So the application developer might have questions like which sub device I should configure first, or is this the right way to do it, or what is the format that needs to be configured for the entire media bus. Multiple nodes for a single camera device. The application developer only needs to care about that. This is a camera. This is how I configure it. So when in the absence of lip camera, he or she has to deal with multiple video nodes. For example, metadata video node, CSI2 receiver. In the ISP, it itself has multiple nodes, M2M dewarper. V4L2 alone isn't enough because when the ISP comes in the picture, the sensors are really raw sensors. They are not RGB or YUV sensors, and YUV sensors are becoming obsolete. Laptops are now using complex cameras. One example is Intel's IPU3 and IPU6. These are really complex cameras, and we need support for like the lip camera has to pitch in to have a consistent API interface to access those cameras on Linux. Embedded devices are already using complex camera. The example previously I gave you around Raspberry Pi's autofocus module, it's a complex camera. But OEM needs custom solution to manage these cameras, and I'm not sure, Ubuntu had shipped a very proprietary camera stack for Intel IPU3, where we discussed with them like lip camera can be a solution. No portable mobile camera application. As I said, the application is very much tied to the underlying hardware when a complex camera is involved. So portability is just out of the question. But there is a new API, and lip camera aims to solve it. The problem is lip camera needs to have very good kernel support for, like, the sensor driver should be upstream, the ISP driver should be upstream, and then only the lip camera comes in and solves the problem. We live in an age where upstreaming itself is a difficult task. There are many BSPs, and BSP kernels and drivers are floating around. C application don't want to use C++. Lip camera is written in C++, but we are working on language widenings as well. Is it finished? Not yet, but we do have releases. We are not guaranteeing ABI stability yet. So after all this, after the challenges and the complications that lip camera tries to address, these are some features and developments. Lip camera has a GStreamer element. That means you can use the GStreamer element to encode, stream, and mix all the other GStreamer elements up and try to get a pipeline working as you wish. So yeah, the example is for the simple camera viewer, JPEG network streamer, and for the receiver as well. We have Python support. So this was first language binding that we landed officially in the lip camera repo. Based on that, PyCamera 2, which is not a part of lip camera, it's a Raspberry Pi's work it's a lip camera based replacement for PyCamera, which was a Python interface for Raspberry Pi legacy camera stack, and many Raspberry Pi users and hobbyists are very familiar with the PyCamera. We do have an Android Helm implementation. The picture you see is running the Chrome OS camera app, and the stream is going through lip camera HAL layer. We do have V4 and L2 compatibility layer, similar thing, LD preload. We will hijack the calls from if you have a lib v4l2, if you have an application based on lib v4l2, you can just swap in, swap out lip camera. As well as test applications. We do develop for our own use and to test the entire library. We do have QCam and CAM. These are very helpful, and we encourage user to just try getting started with these to get introduction to lip camera. We do have a simple hello world for the API, which is like a very simple camera manager starts. I want to get these cameras, run, queue up request, and stop. And you can see what's capturing and how it is done. We do have Pipewire. I'm not sure if everybody is aware of Pipewire. It's a upcoming Linux multimedia stack. Last year on a Pipewire Hackfest, we tried running Chromium, which would go through the XTG camera portal, and it was routed to Pipewire, then to libcamera, then back to the kernel. So we already are working, and it's already merged. I think the Pipewire integration is already there, which has multiple, like Pipewire has a much broader exposure to stacks like video conferencing solutions, browsers. This is the Pipewire stack where the app, the browser, the streamer, VLC are talking to the Pipewire. The Pipewire for imaging can offload its stars to libcamera, and libcamera will deal with the camera's side of things. And for the audio, you have Bluetooth, ALSA, and Pulse audio integration, I think. So the Pipewire really sits in the between for all your video and audio handling. So I have linked our blog for the to getting an introduction to the Pipewire. Snapshot is a upcoming convergent camera app where the goal of the app is to have a unified camera app that can run on both on Linux-based mobiles and distributions. It is incubated in GNOME, so very happy to see that. We do have Flatpak support across. Flatpak support means like you have permission based, like if an application tries to Hello. So the XTG portal, WebRTC now supports XTG portal, and libcamera will has XTG portal support. That means WebRTC can give you frames that are coming through XTG portal, then libcamera, and everything can work. In the near future, when the WebRTC and the XTG portal have been merged, you can really access cameras from your browser. These are two Bugzilla and the Gerrit link for the Firefox and Chromium. Once this is done, you can the browser will be working with libcamera for the video capture support. Another notable development is Pinhole. It's developed by Rafael 2K. Aaron Speak. It's a fork of SailOS Harbor Camera, which is a Qt-based camera application developed for original Pine phone. And the application is really nice because it has manual controls, like you can change and tinker with exposure time, brightness in the UI itself. This is a demo image testing on the PiPhone using libcamera. Waydroid is a container-based approach to like having a Android system on your regular GNU Linux system, and we tried and had integrated libcamera in Waydroid, so you have like a LineageOS image running on your GNU Linux system, where it accesses the camera through libcamera. And I think this is the last one. PinePhone Pro, we test ground for mobile Linux capture for everything. It's a Rockchip RK3399. It's a complex camera with an RAW sensor and ISP, and it's already supported by libcamera. I do have a demo for this. Let's see. So this is a demo for PinePhone Pro, capturing images with libcamera. you can see the initial support is there, but like the algorithms, IP algorithms are still needs to get better. Yep, I think that's enough. And last but not the least, this is a very recent development that I put in the last minute, plug and play Raspberry Pi USB camera. So here is a Raspberry Pi's, I think the autofocus camera that I first showed you, it is plugged into a Raspberry Pi Nano. And through UVC gadget that our team had developed, it can now get plugged into your regular laptops and can be used as a webcam. So you can see the entire the complex camera supported by Raspberry Pi. It's using the Raspberry Pi pipeline handler and IP algorithms, and then can be used just a regular USB camera into your laptops. And so that's pretty much it. Thank you for your attention, and if you have any question, I would be happy to answer them. So not yet, but we are working with devices which have multiple cameras. For example, I think the Chromebooks have multiple cameras, back camera and the front camera. The lip camera can handle multiple cameras, but it depends on how the ISP is configured. Some ISPs only supports like streaming one camera at a time. We do have platforms where multiple streaming and simultaneous use of cameras is okay. We are working something on logical. We are working on something that is called logical camera grouping. So that is like mutual exclusion of cameras and things like that. So yeah, it's still work in progress, but it's much more hardware dependent. What the hardware capabilities are. Stereo vision. I'm not sure. I haven't seen. Two cameras. Okay. I think that's a layer above lip camera that you have to build. You have to get the frames and you know, stitch it. Yeah. Yep. Which support? Pixel binning. You do have pixel binning in the sensor itself when you get the raw image. Yeah. So that's a detail you put in the pipeline handler itself, or like the binning, how do you do the binning. Image plus? With the distance, you mean the focus? I'm not sure. I'm not getting it. The distance. That component. Yeah, it's a control. Control like many cameras have different types of controls. What the camera sensor can support, what the ISP can support. So I think the depth would be one of the controls. If the platform in the sensor can support it, it can be like configured by the application itself. So you can put in. If the platform itself doesn't support, the camera won't expose that it's supporting a depth. James? They do in the Chrome OS. They have their own camera stack, which is I think it's called Cross Camera HAL, Chrome OS Camera HAL. So they are. We do have Chrome OS working with lip camera already. So that's pretty much it. Thank you. Thank you once again.
Thank you, and good afternoon. Thank you, FOSSASIA, for the invitation, the slot to speak. Today I'm going to give a very brief talk about this project of mine, which I did during the COVID time. Basically, some time on hand, right? I could explore whether it's possible to use feed gestures to use that as an input device and also a feedback device to communicate, so that this would be instead of using hands, right, and also looking at the screen. So the problem is that, for example, like I'm not able to use the hand either by choice or it's like because of occupied, right, the hands, and then maybe it's not so safe to use the hand, and possible is inconvenient to speak, or it's noisy environment, not able to speak. And perhaps people who are active, right, instead of sitting at the desk and typing on the keyboard the whole day, perhaps there's an alternate method to stay in connection and at the same time be able to be productive. Okay, so I think as I mentioned, the screen I saw, and basically an alternative to the keyboard and screen. Okay, so the haptic communicator basically allows the user to be able to type and enter message. Works as all the must have the. So the idea is to be able to replicate all the keys on the keyboard, right? So it has at least 101 possible combination of input. So again, what are the possible users who can benefit? I put it into three color code. Perhaps the first one will be due to health reasons, disability, and also the people who wants to stay healthy. The second, maybe the professionals, for example, like surgeons working on operating theater. The hands are very busy, right, operating on the patient. And the eyes have to look at the patient, right? So the eyes and hands are already tied up. So how to, for example, monitor the heart rate of the patient, right? Maybe the beep is too noisy, right? Too many instruments. So another input channel. And then the last category would be the gamers and maybe the virtual environment VR user, right? So gamers could gain an extra competitive edge using this device. So this is a preliminary diagram, and there's a prototype that I made. So it consists of the pair of shoes and also the wrist-worn device, right? So with this combination, this is the some of the patent filing diagram which was submitted. Okay, so this is the results of the one single shoe, right? Not the two pairs. So you can see that you can recognize 76 different gestures with a single shoe. So with two shoes and a wrist, there's multiple possible combination, run into hundreds, right? So this basically is the gesture, whether the predicted match the actual gestures by the user. So for example, if I tap my feet, that is recognized as a gesture. So if I bring my feet to a certain angle, then that is another gesture. So again, this one I think no need to repeat, it's the same thing. So again, the use cases, as I mentioned, right, people with disability, carpal tunnel sufferers, surgeon in operating theater, PC, mobile gamers. So in terms of market, right, you can see that I did a research, and the biggest segment at the highest growth rate would be the fitness, followed by assistive tech. And there's also some potential here in terms of the professionals using this in the line of their work, and also gamers and tech adopters. So what are the alternatives out there, right? So from what I did in my research, I see that the devices out there is pretty basic. Maybe the most advanced would be this shoe, laptop shoe, if I remember correctly. So basically this provides a positioning feedback for users. So for example, the people who are visually impaired can navigate around without any auditory cue. So for example, if they need to turn right after a few steps, the right shoe would provide a vibration, right, to prompt the user to turn right, right? Or even maybe an obstacle in front, right? You can give a prompt by vibration so that the user know that, okay, should stop. And this is really not an alternative. And then on top here, that is a pretty crude, right? Up to 5 keys, but it's functional definitely. And how about the hand-worn devices? Okay, so I think this is a little bit dated, but we have seen this device out there some time back, right? There's a laser-pointed keyboard, but this still requires the hand and tap on the surface, right? Although there's no physical keys. And over here, this device is pretty interesting, right? This tap strap. It's fine. It's fine. The tap strap is worn on the hand. Basically, is tapping of the fingers, right, on a hard surface, right? Depending on how which finger is being tapped and or the combination of fingers being tapped, it could kind of like replicate the keyboard. But again, this also requires the use of the hand, right? So hands and a surface as well. So I did this comparison. So I think the major advantage of not using the hands is that you free up the hands, right? There's a given. And then there's also a free up the screen, right? With the feedback, you don't need to look at the screen. You can focus on other more important areas, right? You can even, like, as I mentioned, like gamers, their eyes already busy, so many things, right, in front of them. Okay, so what about vision-based AI gesture? There's other alternatives out there, right? So this is some of the things that is done and available. For example, using a camera to recognize hand gestures. Even open source libraries are already available. So pretty impressive. So the problem or the limitations would be requires a clear, unobstructed view, right? And then the lighting condition also has to be within condition, ideal. And of course, I think the image processing workload is a bit heavier. And there may be privacy concerns, right? Because you wear a camera around, people will be a bit suspicious. And how about the proven basic voice communication? Just use voice call, right? Speak like a phone, right? Of course, this one also requires a background that is a bit not so noisy. And it may not work that well with if the target is not another human being, right? You need to translate that into a machine code or, for example, activate machinery. So also has to be discrete, right? So for example, if you are a negotiator, business negotiator or presenter, so you may not be able to speak anything else, right? You have to just use some gestures to show, for example, time to cut the camera. Okay, again, so in terms of market, I can see that this is from the public data basically. So we can see the wearables market is growing very fast, right, for the next 10 years or so, right? 12.4% CAGR. And you can see that even the mechanical keyboards were pretty popular with gamers, right? So it's followed by the market. So it's in the related segment. It's all growing, IoT. So that is the market segment that was being pursued. So I think what are the things that we can do to, I was thinking, right, could drive this adoption is maybe gamify it, right, in a way, right? People sharing gestures, one training gestures that is trained, because otherwise the standard gesture may not work for every individual, right? Some people, depending on the culture, we may not reflect exactly the same. So I think with the 2 years since the last update, I think now it's even easier to do this because of the improved AI processing capability. And then we can even have the additional like Wi-Fi 6 and Bluetooth, which basically improve the reliability, right, and performance and power consumption. So that's all for my presentation. Get in touch and let's see what can be discussed. Okay, thank you. Yes.
The second slide, you had these sort of spheres,
Mm-hmm.
yeah? And you said that the most likely, I think the most likely market was fitness. What was the source of the data on that to determine that fitness is the most likely market for?
Okay, let me just put this back. You mean this one? Oh, this one. Okay. I had the link in the detail original document, right? So it's definitely from one of the research market research firm, right?
When you say fitness, what kind of fitness activities do you think this will be suitable for?
Oh, okay. Okay, I think I did put in some kind of picture. Oh, okay, it's no longer there. Yeah, probably less movement on the feet, maybe standing, a bit of stretching, right? So at least variety of usage. So instead of just sitting down the entire 4-hour stretch, right, you could like do a bit of stretching while, I mean, there's always demand for certain gadgets. Nope, sorry. Yes. Thank you. Thank you.
Sorry about delay. There's some technical issue related to the sound. I'd like you guys to welcome Paul on the stage, which is about to introduce us to live coding music with Sonic Pi, which sounds really fun and interesting. So everyone, please give a round of applause to Paul here. Thank you.
There's one more I haven't tested for a while ago. Yeah, just a moment. Let me just test this and then we can go on with the presentation. Okay. Okay. I think we're good. Let me just open this. Okay, let's start. Hey everyone, I'm Paul. I'm a developer during today and during the pandemic, and then during my free time, I usually dabble with music. So this is my hobby. I don't get paid for producing music. I just my passion to do so. So what I'm doing here today, that's my passion. That's what I'm sharing here with you. And just a shout out to my friends who are here today. I'm very happy. My friends from DataKind, BDX, from the community, my friends from the workplaces that I used to work to, and the whole FOSSASIA family and the tech community here in Singapore. Welcome. Thanks for coming here. My Filipino friends there. Thank you. So, what is Sonic Pi? Sure. Sonic Pi is the marketing thing that they put there is, but it's for me it's just a platform so that I can do some coding, and this code magically turns into sound. So I can trigger my bass drum, my drums. I can trigger my synths, my guitars, and so on and so forth, while playing sort of or performing live. But I think I can demo this more by doing it coding, live coding, like how I use or how people use Sonic Pi. So before that, our set list for today is very simple. We'll just make some notes and chords, the basic ones, make some drum beats to support our music, use some external synths if the sounds or instruments inside Sonic Pi is not good for you, you want to use your own synths, I'll try to show you that. And then ultimately make that as a backing track, and then I can just play my guitar. So let me open the Sonic Pi. So I'll just clear this off. And then I'll just show, oh yeah, Yoke is my friend from DataKind, so I get help to hold the mic. So the basic concept of making music in Sonic Pi, we just hit play. Play is our command to play the music. So I'll just put some number there. So if I play this, can you hear it? That's the note C, I think middle C on the piano, if I'm not mistaken. But at first I thought this is like the frequency, but when I checked, it's actually a MIDI note, so a MIDI number that corresponds to a note. So if musicians don't really want to type MIDI notes when composing music, you can always put your MIDI note or your musical note as the letters. So you have C4, so C fourth octave, and it will sound the same. Yeah. And then, of course, let me get my sheet that I prepared for this. You can see that the both notes are exactly the same. Select all. So one thing to note on Sonic Pi, if you're doing copy paste like Control C, Control V, it will be Alt, Alt C, Alt V in Sonic Pi. So that's the same. And then, of course, because since this is a programming language, if you're familiar with Ruby, Ruby is not my first language, but it has the basic syntax and then looping structures. So if I want to play a sequence of notes, you can just do something like this. For each note, it will just play. And then the sleep code that you find there, that indicates how long the note is played. For this one, this means that it will be played for 1 beat or 1 count. So 1 count for each note. So this is like playing C in octaves, C3, C4, and I think C5, which you can also replace if you don't want the numbers, you want the actual letter notes. You can do that as well. So it's the same. And then if you want to have, I think you can search in the web on what note is equivalent to what, or you can just see here. So you have all the octaves and then the corresponding notes on which octave you want to play. But I don't really use the numbers usually. I just use the C5, C4 to make it like musical in that terms. And what about if I want to play 2 or more notes together to form a chord? So what I have here is a C chord. C chord is a triad of like C, E, and the G note that forms a triad of C. So I'll just play that. So V. So this one, what I'm doing here is I'm going to play each note individually, C, E, G, and then I'll play them as a chord. So if I don't put sleep in between, they will be played as one. Yeah, that's like you've arrived at your elevator level. So let me just get to the other approach. So if you don't want to type all the lines, since this is a programming language, you can just look through each of the notes. So I'll just copy that and then place it on Sonic Pi. So here, it will play each of the note with an interval of half a beat. So let me run that. And then if I want to play them together, I'll just remove the sleep. And then it will play all 3 simultaneously. Yeah, all 3 notes. And then, if people just want to just play chords, you can. Sonic Pi has a way to just for you to indicate just the chord and then the corresponding type of chord that you want to play. So let me just do that. So here, I'll just play here. So I'm going to play a C major chord, the one that you just heard. It's the same chord, that one. But if I want to play a minor chord, here you have minor. You can actually it has intelligence or autocomplete, so you can choose what chord you want to play. So here I'll just change to a minor, then I'll run. And then if I want to be like fancy and then do some major seventh and stuff, then you can do also. It's a very faint, but yeah. And then that's for how we do with the notes. But you want to have a way to loop the notes so that you can have a sort of pattern that you can play over and over again. So let me introduce live looping. So here, I'm just going to play a chord for every beat. So let me just show that. So for every beat, you can hear the note, the chord, I mean. And then let me just stop that. And then usually for chord patterns, you have like a few chords, so you can have transition. Let me just show a bit of that as well. Let me just show. So here I have C sharp minor, and then E major, B major, and then A major, and it will loop. Is there a way to increase the volume? This is the loudest it gets. It's okay. Yeah. So any EDM or Avicii fan here? So I got this from one of his tracks previously. I mean in the early 2010s. So this is the chord pattern. Let me just get that. And then here, we can have a shortcut way also. So like we did some shortcuts on the previous demo, we can save a lot of typings by just looping a certain progression. So this progression, I can just store in a variable, and then I can just run it, play it in the loop. So what we have here is a way the chord pattern. So the ring means it will just, and after the last chord, it will just loop back to the first chord, right? So the tick here is just to invoke the next chord in that sort of pattern. So if I play this, it will be the sort of the same, but the structure is different. But it's the structure we have made it as a little bit simpler so that we can manage later. Yeah. So let's do this. So the next one that we'll want to show is, so we have the chords. We want to put in some melodies. So let me share that a bit. So here, let me just do that. So when we do the melodies, it's like what you saw a while ago. I place here some notes, and then do some duration on how long that note is. And then if there are like two notes that I want to play, I just put that 2 times, play that note, and so on and so forth. So what I did here was I encapsulate that that part or that block of code in a function so that I don't keep writing it again and again, and then call that later. And then there's a melody for the ending part as well, which is repeated twice. So what I did was, for that live loop, I just invoke that function to play that part, play the distinctive for the first measure or first bar, and then do the repeating part, and then the distinct part for the second measure. And it sounds like this. So this is the melody part. So what we're going to do next is, how about if we combine the two? So we have the chords, we have the melody. Let's do that. So that's the combined version. So I'm going to start. Then we can find the chords, and then as well as the melody. Next one will be it's quite plain, it's just melody and chords. Since this is EDM, one of the factors of EDM is to have the beat, like a chug chug beat. So let's put that chug chug beat. So I'm going to copy this and then introduce them. and then and just comment this out for a moment. So alt slash, and then we have this one is like it does nothing, but since we are going to have multiple drums and then parts like hi-hats, bass drum, and stuff, I just put there as a metronome, so it will sync to that live loop, and then so that when we add the instruments later, the sound will be in sync. So this one is our chug chug. Where's the chug chug? There is. So it's like 128 beats per minute, and it's driving for each beat. And then what we're going to add now is we want the. So we're going to add some snares. Actually, in Avicii does the claps, but I don't have a clap sound here. So instead of clap, I'll just do what you call this? I'll just do snare instead of a clap. Should be there. And then, although this won't be the EDM style because I'm going to add some hi-hats, but just to demo how it works like a drum kit. So this one does it for every half a bit. And then usually you want to know what is the start of the measure. So every like maybe 8 counts, I'm going to hit the crash symbol. Okay, let me start that. 2, 3, 4. 10 minutes. Okay. let me stop that, and then so that we can do more. Sometimes I get carried away when doing this. So let's do all the melody and then the drums. Let's B. So what we're doing here is we added the drums. So I removed the hi-hat, just the kick and then the snare, and then the melody, and then the chord progression. The melody, chords, and with our drum and snare. So let it play. So in the song, there's this section where we have the riff that sounds like something like that. So we're taking that. So here, there's an octave shift kind of. So just stop this one now. And then run that. So this is what we want to do is some sort of octave shift. But this one doesn't slide. We want it to slide. So there's a option here to do the slide, but you need to put some a note in between so that it can actually slide. So what it does here currently, every 4 counts it will play the lower note, every 4 counts it will play the last sort of note. But to achieve the slide, we put in some notes in between. So let me stop this. So I just added an extra note. So for that particular 1 count at the last beat, so that you can hear the slide. And then slide. And then here you can also use other synths. This is a piano sound, but in them you can use other sound and stuff. So I'm just going to change it to this saw sound. The slide is good. So that is like one riff effect. Let's do this. And then the other one is if we want to use an external sound, like here, I have another sound here called bespoke, but it doesn't sound. Oh no. Okay, I'll skip that. Let me just let me check if I can open it again. Otherwise, I'll skip it. So instruments, keyboard. Where's the keyboard? Okay, it sounds now. So this is a Vital. I'll show you later on how is that, or to get that. But I'm going to use that as my external synth. And then here, I'm just going to call an outside synth. So, let me just run it. So Bifrost, if for Star Wars, Avengers fans, this is I'm using Loop MIDI to connect my Sonic Pi to bespoke synth, and I call my connector Bifrost. So that synth that you hear, that is from bespoke. This is the one that you're hearing. This one is here. And then this is the one that Vital is an open source tool. And then you can choose any patches there. And then lastly, let us combine everything with drums and then the synth and all. Okay. Is below. I think the drums. Drums, you have it, the snare, and then the kick. But there's we did we did the octave, right? Let's add that. So I will take it up a while ago. If we want to add that, then you should hear that noise. I can play more guitar, but I think I'm short of time. We can do more. So here, let me just remove the main. You can start to stop part here. So let's say you want to stop the string and then just do the tube thing. You can do that as well. So I just put that there. And then remove change it to piano. So I haven't rehearsed this, but this is something like if you want to know more, you can go there. That's the Sonic Fly website. You can download, I think it was in Mac, Windows, and I think this comes with in Raspberry Pi. If you have Raspberry Pi, I think it's built in. For the code, the one that you saw a while ago, I tried to upload there your code run. So, it's been rough. And then the bespoke synth is the one that I showed a while ago, the one with the green thing with the visualization that pops up. You can download it from here, or if you want to see my talk last year, I talked about bespoke synth in FOSSASIA as well. And then look within, think of it as Bifrost, I think that's the one that helps me connect my MIDI sound from the Sonic Pi and into the bespoke synth. So this is how it connects. And Vital Synth is another open source thing that if you heard about like maybe Avicii or Skrillex and those wavetable effects, I think this is like one of the open source that can introduce those kinds of sounds. And then that's my Twitter and GitHub. And if you want to hear about the music, I uploaded, I produced some music during the pandemic. So I placed it there in SoundCloud. Feel free to hear if you have some free time, just download or hear various music. Usually I play about guitar tracks, some piano tracks, during my spare time. Thanks for coming, thanks for experiencing Sonic Pi and sound. And yeah, thank you very much for being here.
Thank you very much. It's been amazing. Paul, do you have any questions for Paul here?
Thank you. Just a question. The sound library. Let's say I got a very big sound sampling library. I got.
Yeah.
And can I actually import it into
That's
one of these
cool.
and
Yeah,
replace in the different sound and make a
That's
different sound?
yes, that's but I didn't get a chance to demo it. But there's an option to load external. So the sample here, where's that? Did I use some sample? The sample drums. You can just add the path to that wave file. So you have a sample, right? Just add a wave file and then it will play.
Oh, I see.
Yeah.
And
So
can-
sample space and then your wave file.
And can you also make the special effect for the sound or
Oh yeah.
effects for that?
Yeah, so there's what you call this adding
there.
effects. So let me just do this thing. You just didn't get a chance to demo it, but you can whatever's inside, you just encapsulate it with underscore effects, and
Okay.
then you can put reverb. There's an I think echo also distortion.
I see. I see.
Yeah, and then just encapsulate it, and then whatever's inside. Although I think at first I was planning to put in my guitar as an input. I mean, you can do it with live audio. There's a live audio thing. It's just that there's a challenge with latency.
Yes.
So what I did was every sound coming from Sonic Pi, just one stream, and then if I need to play along with it, I put it separately so that
So
this
you-
will be
you
sort of
minimize the
backing
latency.
track.
I see. I see.
Yeah.
Great. Yeah, thank you.
Nice. Yes. I think I haven't tried that much. If you push it at least to bespoke, bespoke has ability to. So this is stereo. You have left and right channel, right? If you put in your MIDI output in, let's say the loop MIDI, then you can have that stereo effect. I think this should be stereo, but I haven't. Delve with that deeply. There should be some stereo, forced mono, or I think it's default by stereo, I think, but can explore. Yeah. Anything else? Yeah. Thanks everyone.
Yeah, thank you very much, and I hope you guys enjoy your day so far. And we're about to have a closing ceremony in the lecture theater at 6 o'clock. So yeah, if you don't want to make your way up there, and at 7 o'clock, if you guys there's an at 9 o'clock at Hackerspace. There will be a small gathering. So if anyone interested. Thank you very much.